Hey everyone, welcome back to HackProKP. My name is Klash Prashad, and in today's video, we are diving deep into one of the most important protocols in the world of networking, the TCP, or Transmission Control Protocol. Whether you're preparing for the OSCP or just brushing up your networking fundamentals, you're at the right place. In this video, we will explore what TCP is, how does it actually works, how does it enable reliable data transfer within applications, but most importantly, we are going to actually look at a sample Python program that I have created for simple client server TCP communication. In that, we will actually check out the raw packets by using Wireshark. And don't forget, you can find all the demo codes, the special notes for today's video, and the TCP dump file in the video description. Be sure to check them out. What is TCP protocol? TCP is a reliable data transfer protocol that implements on top of an unreliable IP end-to-end network layer. Now, this IP is Internet Protocol from Layer 4 or a network layer. Transmission Control Protocol is a connection-oriented protocol. Some of the functionalities of this protocol are: this is a point-to-point protocol. This means that there will be only one sender and only one receiver. This is reliable. This means that it ensures integrity of data. In-order byte stream is there. This means that data is transferred in order. Pipelining is there in this protocol. This means that it has mechanisms to prevent congestion in the network and has mechanisms for flow control as well. So let us consider that the sender, for example, doesn't really overrun the receiver. We're going to talk about this later in the video. Now, this protocol also follows full duplex communication. This means that both parties using the protocol can send data to each other at the same time. This allows for bidirectional data flow. What is the maximum amount of data that can be sent at a particular time? That is known as maximum segment size, or MSS. Now, as I told you before, that this particular protocol is connection oriented protocol. This means that handshaking is required before data transmission. Now, this data transmission, whatever messages that are sent before data transmission, are also known as control messages. Now, these messages actually initialize the sender and receiver states before data exchange. The TCP segment structure. TCP segment structure can be quite complex, as you can see on the screen, but let us break it down. First, let us start with source port and destination port. Now, source port and destination port is actually pointing out to the end applications that are running on the end-to-end devices that are actually communicating between each other. So, these are the port number or the addresses of the application that are sending and receiving the data. Afterwards, we can see we have sequence number and acknowledgement number. Now, this sequence number is actually from the byte stream, the value of the first byte of the segment's data. And the acknowledgement is actually the sequence number of the next byte that is expected from the other side. Now, both of these, the sequence number and the acknowledgement number, are actually counting by bytes of data and not segments. This is important. Now, let us take a look at the control bytes. That are the 6 bytes that you can see over here right now. The first one is URG, or urgent data. This is generally not used. The second one is acknowledgement, or acknowledgement of the data. This is actually sent when we are acknowledging that the data has been received by the other party. The third one is push, or push data now. This is also generally not used. The fourth one is reset. The fifth one is send, and the sixth one is fin packet. Now, these are connection established packet setup tear down commands. That's it. Nothing more complex. Now, SYN is important and FIN is important. SYN is used for connection establishment, and FIN is actually used for connection breaking when we are terminating the connection. Now, you can see at the right we have the receiver window. Now, that is the number of bytes that the receiver is willing to accept while transmission. Below the control bytes, you can see we have the checksum. Now, this checksum is similar to the UDP protocol, nothing new. Now, let us talk about the three-way handshake. Three-way handshake is a process which is used in TCP/IP networks to establish connection between servers and clients. It uses a SYN-ACK sequence to make that happen. Now, let us discuss this in detail. So, now you're able to see an example for three-way handshake on your screen. You're able to see that a client is trying to communicate with a server. The client sends a synchronized packet of value 1010 to the server. It gets a SYN-ACK packet back from the server with the values. SYN packet is 2020 and acknowledgement packet is 1011. If you remember, the SYN packet was 1011. So this acknowledgement packet that we received was +1 of the SYN packet. And afterwards, the client sends an acknowledgement of 2021, that is plus one of the 2020 packet, the SYN packet that was received by the server. So this is the example of three-way handshake. Now let us talk about reliable transfer in TCP protocol. TCP must recover data that is damaged, lost, duplicated, or delivered out of order by the internet. TCP achieves this reliability by assigning a sequence number. Now, this is important to each octet it transmits and requiring a positive acknowledgement ACK packet from the receiving TCP. So now you're able to see an example of host A and host B trying to communicate over TCP protocol. We are ignoring the connection building part and now we are actually at the data sending part. Okay, so host A wants to send message C to host B. So first, it creates a packet with sequence, acknowledgement, and data. So we can see that sequence is actually set to 42, acknowledgement is sent to 79, is set to 79, and data that is only 1 byte is C. Now you may think that why it is 42 and 79. So actually this is completely random because this is the first data transfer that is happening and no data transfer had happened before this. That's why this is going to be completely random and completely randomly generated by host A. So that can be any other number as well. Now this packet has been sent to host B. Now host B receives this and now he has to send an acknowledgement back to host A telling that he has received data C. So what is going to be in the receipt of data C? So receipt of data C will actually have C data as well. So it creates an acknowledgement packet. Sequence number will be 79 and acknowledgement will be 43. And data is sent back as C. Now you can see that the acknowledgement is 42 plus 1. Now 42 was the sequence that was sent before by host A. And as we are only sending 1 byte of data, that is C, that's why 42 plus 1. This is actually pointing out to the next byte that host A want to send. Now host A receives the acknowledgement of C. So it knows that C has been received properly by host B. Now they can send any other messages that they want to. So they are actually sending a sequence number of 43 and an acknowledgement number of 80. Now, if you see, the sequence number that was received by host B was 79. And this acknowledgement that is being sent is 80. So pointing out to the next byte. And sequence number is 43 as before because we are actually pointing out to the next byte of data that we want to send. Now, this is how the communication is going to be happening in a simple TCP connection. And now it is lab time. So let us check out the two programs that I have created for simple TCP communication. And we are also going to check out the raw packets transferring in real time by using Wireshark application. So let us start that.
Okay. So guys, you are able to see that I have running my Wireshark program by using the terminal sudo Wireshark. After I have run this, I'm going to select loop back over here as an adapter, and this is done. And if you can see over here as well, I have the server file and the client file over here. So what I'm going to do first, I'm going to start the server first. So you can see that server is listening on port number of 1, 2, 3, 4, 5. And it is looking at all the addresses because this is 0.0.0.0. That's why I've selected loop back over here. I'm going to go to TCP client and I'm going to start in a dedicated terminal. So you can see that there was some communication of 3 messages. So first of all, let us see. You can see the first message is a SYN packet. You're able to see a SYN packet. This means connection building process is there. This is the handshake process over here. SYN act from the server back to the client and act from the client to the server. So this is the three-way handshake that we're able to see over here. So the transmission control protocol that we have to open. This one you have to open to see the packet. So you're able to see the host port, the source port, and the destination port. You're able to see the sequence number as well over here. And the data, this was a flag that was sent, SYN flag. You were able to see the SYN flag was sent over here. So now let us close this. And now we are going to send a message to the server. So let us type HackProKP. As you can see, this is the message that I'm going to send. I'm going to send enter, and this was sent to the server. So let us see the server side of the things. You're able to see that server received this. So now let us check from here as well. So this is the push that we are able to see. So now we were able to see the conversation, the port over here as well. This is the sequence number. Let me double click it so that it is easier to see. You're able to see the source port and the destination port. The sequence number that was used and the acknowledgement number as well. The flag that was used was push with acknowledgement. This is the window size. You can see 65536. This is the TCP packet that was sent. And now I'm going to quit the communication. For quitting, what I have to do, I have to type exit. So let us type exit. So connection was stopped. So if you will see over here, for connection stopping, we are using FIN packet. So FIN acknowledgement, and acknowledgement. This is going to close the communication that is happening between the client and server. So that is all for the lab part. I want you all to download these files. And if you're not able to run this, I have actually made a dump of this particular thing. So you can actually open it with Wireshark as well on your Windows computer and actually see the packets.
So now we are going to check out more examples to understand this very clearly. Let us start with first example. So we are able to see two hosts that are host A and host B that are communicating with each other. Host A sends a sequence number of 92 and 8 bytes of data to host B. Acknowledgement packet of 100 was created. 92 plus 8. We have discussed about this before as well. Now, for some reason, this acknowledgement got lost. So what happens at host A? After a certain period of time, a timeout is going to occur. So this data, the packet that was sent before, is going to be retransmitted. So that retransmission occurs. Sequence of 92 and 8 bytes of data is sent again by host A to host B. Now B knows that the acknowledgement got lost because it has already received the data. So, and this is a retransmission. So it just simply ignores the data and sends the acknowledgement back to host A. Let us take another example where host A and host B are communicating again. So the window size is 2 over here. So 2 packets have been sent at the same time before the acknowledgement can be received. So sequence number of 92 and 8 bytes of data has been sent, and sequence of 100 and 20 bytes of data has been sent to B. Now the acknowledgements were created and they were sent back to A. But what happened before, because of internet delay and all, they got received after the timeout period occurred for sequence number of 92. So as no acknowledgement was occurred within the timeout period, so what host A did, host A sends the sequence number of 92 and 8 bytes of data again. So it retransmitted the data, the first packet. Now as acknowledgements are cumulative, we know about this. Hence, B has all the data up till 119 bytes. So it sends an acknowledgement of 120 directly to A. It doesn't really send both of the acknowledgements together. It sends the acknowledgement of 120 and not the acknowledgement of 100 because it has the data till 119 bytes. So it wants 120 bytes data. So acknowledgement, we know that it was the next byte that was expected. So it sends acknowledgement of 120 back to A. So let us talk about example number 3. Here also A and B are communicating with each other and window sizes too. The similar previous example, but with a small change. So sequence number of 92 and 8 bytes of data has been sent, and sequence number of 100 and 20 bytes of data has been sent to host B. Acknowledgement of 100, that is for sequence number 92, and acknowledgement of 120, that is for sequence number 100, have been created and sent back to A. But for some reason, acknowledgement of number of 100 got lost. But the acknowledgement number of 120 got received before the timeout period occurred for sequence number 92 over here. So this is actually happening before the sequence number of 92 timeout period occurred. So as the acknowledgements are cumulative, So A knows that B has received all the bytes till 190. Hence, it knows that the acknowledgement of 100 got lost because that was not received. And it is going to continue to send the messages above and after that. So sequence of 120 has been created and 15 bytes of data, 15 bytes of data is sent again. So that is how the data transmission, the reliable data transmission is going to occur in TCP. There are three key phases in TCP's congestion control that are slow start, congestion avoidance, and congestion detection. Let us see a graph to really understand this thoroughly. As you can see, the vertical axis is representing the MSS or maximum segment size, and the horizontal axis is representing the time. So, first, what happens? We are in the slow start phase. The sender starts by transmitting a small amount of data, gradually increasing the rate as long as the network can handle it. In this particular phase, we are getting all the acknowledgements back correctly. After some time, we are in the congestion avoidance phase. As the network becomes more congested, TCP avoids overwhelming it by adjusting the transmission rate. This helps prevents packet loss. So what happens in this phase? Some of the packets, some of the acknowledgement packets are getting lost. Some little bit. So after some time, congestion detection phase is there. If packet loss is detected, which signals network congestion, TCP reduces its transmission rate to further down ratios. So this is going to be the congestion detection phase. Now after this, it is trying to find a sweet spot, the maximum segment size, on which when it is able to find that particular maximum segment size is used to further sending all the messages to the receiver. So this is the congestion control mechanism in TCP protocol. To summarize, TCP ensures reliable transfer through mechanisms like three-way handshake, retransmission of lost packets, and congestion control to optimize network traffic. That is all for today's video. Thank you for watching. If you like this video, please hit the like button and get subscribed to help me with the algorithm. Thank you again and have a nice day.